Hello, so I'm going to be going over the solutions to the algebra review homework. I'm just going to look at the 5 that I wanted you to turn in. I've already went through and graded everyone's homework based on completion, so if you went ahead and finished each of them and showed the right work, then you got all the credit. I think most everybody did a really great job on that. Also, we have our quiz tomorrow, so just probably a good idea to pay close attention to how I present these solutions. You want to emulate them as best you can on that quiz. You don't want to lose any points just because you forget to show a step or you don't do a problem in kind of an accepted fashion. So in this first one here, we're supposed to solve this equation for D. First thing that you want to do is multiply both sides by 3. Now there's many other ways you can do this. You can subtract C on both sides if you want, but I think this is the quickest way to do this kind of problem. So you're going to get 3C equal to 2D plus 1. And then from here we could just take away 1 on both sides and then divide by 2. So your final answer you can write as 3C minus 1 all divided by 2. And there are many ways you can write that. You could write that 3C over 2 minus 1 over 2. You could also write it minus 1 over 2 plus 3C over 2. But we do want to just get D by itself, and that's pretty much it. On this second problem here, this is a system of equations they wanted us to solve using substitution. This top equation, solving for n, is probably the easiest one to start with. So I'm going to take that equation over here, and if you subtract 2m, as in mo, you will get n equals 6 minus 2m. Okay, now that we have n, really bad variables to pick next to each other, we have n in terms of m. We will plug that into our other equation. You cannot plug it back into the equation you got it from because you're just going to go in a circle and it won't really solve anything. So let's see what happens when we do that substitution. 5m plus 6 times n is 6 minus 2m equals a 1. You want to distribute in. And then combine like terms. Let's see, minus 5 and, positive 5 and minus 12 makes a negative 7. And if you subtract 36 on both sides, you'll get m is equal to a positive 5. Okay, I had some students stop right there. Be really careful because we need to solve for both m and n. So now what I'm going to do is just plug that in over here. N equals 6 minus 10, which means I get a negative 4. Totally acceptable to write our answers like this. If you want to write it as an ordered pair, you got to use those parentheses. I would suggest just not doing that because a lot of people forget that and it will cost you like a quarter of a point or something on the quiz, so just be really careful of that. Next one, another system of equations they want us to solve using elimination. I think this one will be solved pretty quickly by maybe multiplying. I'm going to divide the bottom by a 2. So I'm going to multiply the bottom by a half, same as dividing by 2. So that's going to give me 2x minus y equals minus 4 minus 2x plus y equals 3. Okay, and so if we were to add those things together, you might see that we are going to get one of those weird cases where we get a false statement. So that false statement is going to look something like 2 equals 4, or some absurd thing that we know is not true. So let's see what that's going to be. Add those together. Those cancel. 0 equals negative 1? What? I don't think so. So this is a false statement, which means our final answer would be no solution. Alright, next we have some quadratics. Number 19, we have to subtract 4x on both sides. Okay, what I'm seeing a lot, well not a lot, but a fair number of students, and it's a common mistake, they write this as their next step. But then, like, we had an equation, but all of a sudden there's no equation. Be sure you don't forget to put equals 0. We need an equation if we start with an equation. Equations don't just disappear. From here we want to see two numbers that multiply to minus 21, add to minus 4. Looks like negative 7 and positive 3. Also be sure to have equals 0. Don't forget that on your quiz. It might cost you a point or a fraction of a point, because if you don't add that, it's not technically a true statement, because you can't start with an equation and then just not have an equation. Now we can set each factor to 0. From here it's totally fine to say x equals 7, x equals minus 3, and then you're good. On the last one, and also when you double check this one, I had a couple people, and I'm glad they were doing it. They were just checking that all answers worked. That's a really good idea. They plugged in and they kind of threw out one of the solutions, and I had a few people do this. Just be really careful that you use order of operations correctly whenever you're checking your solutions. Like when you square a negative, make sure you get a positive, so on and so on and so on. Both of these actually will work if you plug them in correctly. I'm not going to require you to check your solutions on the quiz, but I think if you got the time, you might as well, just to make sure that they're all good. Last one here, well, let's see, if we divide both sides by 3, we get a negative 18, because a negative divided by positive is negative. And now whenever we take square roots, square root of a minus, for our class we're going to say, probably the best thing to say, no real solution, or no real number solution. Algebra 2, you'll learn that there are two solutions. They're just called complex numbers. So pay close attention to those steps that I have in there. Also notice how most all of this work, I would assume, is kind of easy to follow from beginning to end. If you were to show this to any other student in the class, they compare this to the beginning of the problem, they can see, oh, this person must have multiplied both sides by 3. And here's the result of doing that. And then from here they must have taken away a 1, and that's the result of doing it. I am seeing some students, and I just want to kind of prevent this early on, whose work just kind of seems to go in like all kinds of directions. And I know that's kind of a hard habit to break, but we want to make sure that we clearly communicate from beginning to end in a clear and logical order. And those directions will be on pretty much every quiz and test we have this year. Show all necessary work in a clear and logical order. Where that tends to be a problem is usually with these systems of equations, because you can kind of go in all sort of weird directions. If you do something like this where you kind of draw these arrows, I think that kind of helps. But just do try to be as organized and as clear as possible. If you have any questions, feel free to email me. Our first quiz will be tomorrow, shouldn't take too long, and I look forward to seeing you all then.